Okay. So homework for today was to get our starting point for our towers so you can move discs around, right? But not actually necessarily apply any of the Towers of Hanoi rules to it. Basically just have it so you can have some movement and create a probably a Towers of Hanoi kind of game class. So let's look at that. So we'll go ahead and, because right now we have what I create 3 discs, or I create a tower, I push the discs onto the tower, I display the tower. Okay. So we want to think about what is the Tower of Hanoi game. Tower of Hanoi game is a collection of 3 towers. It starts off with all the discs on the far left tower. All right. So we want to go ahead and create that. So we'll call this guy TOH HPP. All right, and we'll have class TOH. We'll have a private section. We're going to have to go ahead and include tower.hpp. All right, because inside here, we're going to need to have 3 towers to work with. Now, we can do this a couple different ways. You can have 3 individual towers, or you can create a collection of towers. Maybe you have an array of 3 towers, so that you can conveniently move stuff from tower 0 to tower 1 to tower 2, rather than have to have a bunch of if statements that say, well, if you put in a 0 as your source, go to tower 0 and take the value. And if you put tower 2 as your destination, push it on to tower 2, so on and so forth. So I'm going to go ahead and do this as an array of towers. So I'll create a tower pointer array. We'll call this guy the towers, and there's going to be 3 of them. All right. We don't need to keep track of the individual disks, so go ahead to the public. We're going to have a TOH constructor, and this guy will take in no parameters. And then we're going to have a display method, so we can have the game display itself. So let's go write toh.cpp. This guy will include TOH HPP. We're going to implement these things. All right, so our constructor here, we're going to add to our collection of towers this, the towers at bucket 0 is going to equal a new tower. We'll put a new tower at bucket 1 and a new tower at bucket 2. All right, and then we're going to go ahead and put our discs onto tower 0. So we'll say this, the towers at bucket 0, which is a tower. We will push a new disc So we need to include disk HPP. We also need to include tower, but actually tower knows about disks. So if we just include tower HPP, we'll have access to disk. So we're going to create a new disk of size, what do we do? 1, 2, and 3 for our examples. So we'll push that guy on first. Then the disk of size 2, then the disk of size 1. So constructor for this guy, fill up our array with the towers. Add to the far left tower our 3 disks in the right order. Display, we're going to go through our 3 towers. Orient I is equal to 0, I is less than 3, I plus plus. Interesting thing here is that we are not able to, actually, I'll show this here in a minute. Let me just hard code it as a 3 right now. Arrays are not able to report to us their size in C++. That was why, if you remember, probably the first week of class when we looked at the command line arguments where main takes 2 parameters into argc, char pointer argv. Argc was the number of arguments. Argv was the actual values that was passed in. So arrays are very much primitive types in older languages like C and C++. But we'll explore that a little bit here in a few minutes. Let's just get this part working. All right, so I'll spin through my 3 towers and tell each tower to display itself. And maybe I can go ahead and after a tower displays itself, I can kick it down a few lines or something like that. We'll put a line of asterisks. Something like that. Give us some sort of visual separation for our tower 1, tower 2, tower 3. All right, so we'll go back to main here. And this guy is now just going to know about towers of Hanoi. So we'll create a TOH pointer. We'll call this guy the game is equal to a new TOH. And then we'll say the game display. Redefinition. Oh, okay, this would be a good opportunity to show that. Notice here it's complaining about disk and tower. Let's see. Clear this in the scope. So if I look at disk CPP or disk HPP doesn't know about anything else. Towers HPP, he knows about disks. So if I were to include tower HPP in some other file, I get with it all the things associated with tower as well as information about disks, because tower relies on disks. So if I go to towers of Hanoi, this guy relies on towers. So I'm bringing in tower HPP. And let's see, class disk. Where's the first error down here? Let's just look at the first one. Previous definition of class tower, and that is inside of tower. And tower HPP. So it thinks there's already a class called tower somewhere else. Guessing that's going to actually have a compilation. Well, it probably won't because it's not compiling. Does it compile all the files in there? Yeah, it does. So the redefinition, that's going to come from an if not defined, but actually it seems like I shouldn't need to do that. This guy needs to know about towers. Haven't done anything special. Oh, I did. That's the problem. I included tower in both Towers of Hanoi HPP and Towers of Hanoi CPP, redefining something that it already knows about. So by removing that, this guy does need to know about Towers of Hanoi HPP, but he can create tower objects here because what came with TOH HPP was knowledge of tower. All right, so then I just need to go into this guy and include IO stream and using namespace standard. Oh, and then I need to uncomment the crap from main, right? So our program does something. All right, there we go. Here's tower 0. Here's tower 1. Here's tower 2. We'll actually go ahead and label those a little bit. I'll make it look nice and pretty. So I'll go back to my this guy and right in the middle here. We'll finish that string. We'll do a thing like this. And we'll do tower. Something like that. So there's my tower 0, tower 1, tower 2. All right. High definition, 4K, great graphics. All right, so now we have our game displaying itself. Now we need to create the ability into our towers of Hanoi for us to say, I want to move something from tower 0 to, for example, tower 2. And have that pop something off tower 0 and push something onto tower 2. So we're going to add another function. This guy will be called, we'll have a return void for now. Yeah, we'll have a return void for now. So we're going to say move, and we're going to say int source, int destination. Then we'll go ahead and implement that guy. All right, and since we're not applying any of the rules, we don't actually have to do any error checking here. You could if you wanted to, but Since we're not actually applying the rules, we're going to pop off tower source, push onto tower destination, right? So we'll say this, the towers at bucket destination, push this, the towers at bucket source, pop. Pop from the source bucket from our towers array, push that onto our destination tower. See how much easier this is? Well, I mean, I know this is a bunch of stuff strung together, but in the big scheme of things, logic-wise, it's a lot easier than having 3 individual towers stored as 3 individual fields, and then having to ask a bunch of questions. If you put in a 0 as your source, then go and talk about tower 0. If you put in a 1 as your source, then we're going to talk about another variable called tower 1, so on and so forth. All right, now we can go ahead and test that. We'll go ahead and say the game move 0 to 2. The game move 0 to 1. And we'll tell the game to display itself again. So initially, we had all the stuff on the left tower, nothing on the middle, nothing on the right. Now we have stuff on all the towers. All right, questions about that? Does that solve everything that I asked you to do for the homework? All right, so now we want to make it a little bit more interactive. We want to be able to maybe read stuff in from the user. I also said I wanted to talk about arrays a little bit. So before we read stuff in from the user, let's go ahead and talk about arrays. So I'll go ahead and create an int array named AR, and let's say it's capable of holding 10 ints. I'm going to go ahead. Let me give myself. Give myself access to do IO stuff. All right, so I'm going to create a new array here. So this is convenient syntax in C++ for creating an array capable of holding this many of these dudes. All right. So if I do cout AR, what do we expect to be printed to the screen? What's the value of AR? Cat, dog, or memory address? Okay. I know most of you thought it was cat, but it's a trick question. So it's a memory address. Remember, arrays require contiguous memory, right? This goes back to what we talked about. We were talking about arrays versus linked lists. Okay, so arrays require contiguous memory. So when I asked for a collection of contiguous memory that can hold 10 integers, it had to go and find me a plot of land inside of the computer big enough to hold 10 integers next to each other. How big is 10 integers? How big is one integer? What's the size of an integer? $32 bits, 4 bytes. 64 bits is a long, 32 bits is an int, 16 bits is a short, 8 bits is a byte. So that means 10 times 4 bytes is 40. This should give me a plot of land that's 40 bytes big. And the very beginning, the driveway or the front door, whatever you want to look at it, the very beginning of that land is stored inside of AR. If I then said cout, we have a function called size of. So now we're digging into memory a little bit here. We see that the size of AR is 40. Proving what I just said, right? That we're able to create a plot of land capable of holding this many of these dudes. And since this dude is of size 32 bits or 4 bytes, right? 32 bits divided by 8 gives us 4, because there's 8 bits in 1 byte. All right, so we printed out the base address. This is where that array starts. And we printed out the size of that variable, which says, yeah, this is 40 bytes big. The plot of land you have working, that you're working with here. All right, so all this was syntactic sugar. And what I mean by that is we could have said, we're going to create a int array, we'll call this guy AR2. And this guy is going to be equal to the int pointer. It's actually going to be an int pointer. It's going to be AR2 of malloc 10 times size of int. And I think malloc might be in standard lib, but we'll double check that here in a second. So by default, malloc, this is memory allocate. It returns a generic void pointer, which I'm casting to an int pointer so that we know how to walk through it. And I'm going to store that inside of AR2, which is a variable capable of holding an integer pointer. And I'm pretty sure this is going to give me an error because I think this function lives inside of standard lib. I can actually test that here on my Mac. I can say man malloc. Yep, that's in standard lib for C. So we'll see the error message here. Oh, didn't give it to me. Maybe it came with standard namespace. Well, whatever. All right, so let's look at what went down here. We got our base address for AR2. I asked for 10 of these dudes. Make sure size of int is 4 bytes. Yep, size of int is 4 bytes. So this is 4 times 10 is 40. Create me some memory that's capable of holding 40 bytes. I said size of AR2. Oh, that's the variable. So I want size of star AR2. Star of AR2 gives me the integer that lives at bucket 0. What is AR2? Why is that guy just 8? I should get an error here or warning saying that I'm trying to cast a void pointer to an int pointer. Okay, that's fine. I'll cast it to an int pointer. Just make sure that's the number 40 as I was expecting. 10 times 4, 40. So Malik creates enough land. That guy right there creates 40 bytes. It's going to return the base address to where those live. Store it in AR2. I'm outputting the size of AR2, which should be 40 bytes. Why am I getting 8 bytes? So 8 bytes is 64 bits. AR2 is a variable capable of holding an integer pointer, but it's a variable. Variable sizes could be, so if I say int, oh, let's do char C like this, and I output size of C, that can also give me 8. No, it gives me 1 because C holds 1 byte. Char pointer C, size of a memory address is 8 bytes. Okay, that's why this is 8. It's saying that the variable AR holds a memory address and the size of that memory address is 8 bytes, 64-bit. It's a 64-bit memory address. Fine. Am I not able to get it to tell me this dude is actually a... See, the issue here is that by creating an array like this, it's flagging this memory location to be a base size of 40 bytes. So I can actually determine the length of this array. So if I wanted to create a function that I could pass an array to, an array that I created like this, and get its length, I can pass it the size of AR divided by the size of the type of value that lives in AR, which gives us our 10. There's 10 buckets in that array. Okay, so we can, if an array was created using this syntax, which actually flags it in the language, and this isn't how it used to work. I think we saw several classes ago that the version of C++ in here is C++ 98, which is a much newer version of C++. It's okay, doesn't really matter. Just this is how the current tool we're using works. So this guy and this guy create different kinds of animals, even though under the hood they're the same animal. This guy actually creates something that is tattooed as being an array. This guy creates something that says, I am the base address of something that is, in this case, 40 bytes long. But what it gave me is the starting point of that. I'm then not able to ask that guy, okay, I know that the value you hold is the beginning of that, but how far does it go? Because he doesn't have the I'm an array tattoo, he's not able to tell me how far he extends. Now, I think we probably could figure it out though. If I create a loop where that equals 0, I is less than, I'm going to purposely go 1 past it. And this kind of breaks the rule of don't assume default values. And I'm going to do a cout AR2 at bucket I. But I want to show the, oh, this isn't going to actually help me. Because it's gonna, they're all gonna be zeros. Oh, no, actually did help me. Interesting. So when I requested the memory, it went ahead and zeroed out all the plots of land for what was just, you know, it's kind of like I requested memory and it went ahead and mowed the grass. got it all set up for me all nice. But it left this last guy who's right outside the fence. That's not our property. We're not going to go ahead and mow this. So you could work around this and figure out a way to write a function to determine the size of an array that was created this way by walking the stuff from the base address until you hit something that was non-zero. That is not a smart thing to do. That's relying on default values. It's relying on a lot of assumptions. All right. So I still go back to my statement a little bit ago that we can't rely on C and C++ based language, C-based languages from that vintage to advertise for us their length. Even though we've kind of seen here that we can sort of kind of dig for it and maybe calculate it. All right. So with that in mind, when we do have an array of stuff that we're passing around, we need to pass with it the number of buckets that are in that array. Or we have to use something other than arrays. But for now, we're going to keep this simple and use arrays. You know, there are things like vectors and stuff built into the language, as there are also linked lists built into the language and stuff like that. But we know how to write our own versions of those now. But in terms of structured data, now we were able to, because of this, I think if we created our arrays this way, and since we're using a new enough version of C++, we could extrapolate and come up with the size. So this would give us the correct answer. Rather than hard coding a 3 in here, I can say size of this, the towers, divided by size of a tower pointer, which should be 8. We'll know pretty quick if this worked. Size of a tower pointer. It's the size of a memory address, which should be 8. stuff. Actually, I'll leave that here for a second. Oh, and del. Yeah, so there's our 8, which means that since a tower pointer is a memory address that points to a tower, the size of that array is going to be 24 divided by 8, which is 3. So this will give us the correct output. So if I go back to this, we'll have our towers displayed correctly. Given all that, if I were writing this, because I know we have exactly 3 towers, I would probably hard code this as a, where's this guy? I just put the 3 in here. We know there's 3, even though we typically will say hard coding values isn't the best plan in the world. In this particular case, it's fine. It's solving the problem we're trying to solve. All right. But hopefully what we got out of this is this is a very convenient way of generating arrays where this is cool, but is a much more primitive thing you get. You get the same size plot of land, you just don't get it labeled correctly or labeled as an array. So it won't necessarily be automatically treated as an array, which means we'd have to play this game of going through and, you know, counting. We could do something like while what did I make it? Int array. So I'll say int pointer cur pointer is equal to AR2. I'll start off at the beginning of AR2 while the value that lives at cur pointer is equal to 0. Do something. What am I going to do? I'm going to be keeping track of a length. So I'll say length plus plus. Then after I'm done, I'll do a cout length. That guy should give me a 10. Oh, I never actually cur pointer starts off at AR2. Cur pointer equals to 0. I do need to set cur pointer. Can I do that? So we're not getting into this. I thought we saw that it was filled up with zeros. Cur pointer boils down to an address. This gives me the what did my for loop look like before. Oh, I used the array syntax. So it's not letting me get at the value of it. Yeah, I could use the array syntax and ask the same question I just did. But for the sake of time, I want to show you how to read stuff in. I'll give you that code as some sample code. If I want to read something in from the user, enter a number. And what we'll do is we're going to say int number. We'll define a variable to hold that number. And we're going to go ahead, we're going to say cin number. Now this is going to get, this will probably give me an error as I have it written right now. And I'll go ahead and do a cout number and L. Let me make sure it gives us the error. Oh, it didn't. Interesting. Makes life easier. All right, so typically with CN, it would have read in a string, and you would have had to use a function like a to I to convert the string it read in into an integer. A to I is a function that takes a string, something that's alphanumeric, converts it to I, an integer, kind of like integer.parseInt in Java. So A to I is a function that does that, but it looks like in here, newer version of C++, CN is smart and it says, hey, you want me to read something in? You're putting it into number. Number is an int. No problem. I got you covered. I'll build an int out of it for you. All right. So that's how we read stuff in from the user. So we use cin to read stuff in from the user. Right. This code as a starting point. So our next homework, expand the code found here, that guy, to allow the user to enter, let's say, to dynamically enter their choices for source and destination, and ultimately play the game Towers of Hanoi. So now you need to implement the rules of Towers of Hanoi, which say that a larger disk cannot be pushed on top of a smaller disk. Submit a link to the code and the self-assessment. Questions about that? So basically what we started with today, except now let the users enter in the source and the destination number instead of hard coding that into our move, and then make sure that move only allows you to make legal moves. Okay, questions, comments, concerns, bribes? All right, I'll see everybody on Monday.